Hi, Professor and classmates. My name is Caroline Park, and I will be conducting the balloon rocket experiment for Lab Report 1. So the whole objective of this experiment is to demonstrate the basic principles of rocketry by applying the concept of pressure and Newton's second and third laws of motion. To give you a little background about Newton's laws, like I said, we're using two of Newton's laws of motion that's related to force. So Newton's second law of motion states that the relationship between the object's mass, its acceleration, and applied force is three of those factors compared to Newton's second law. As far as Newton's third law of motion, it states that for every action, there's an equal and opposite reaction. The whole basis of this experiment, why I chose to do the balloon rocket, was a little bit of background of rocketry. It has existed for about 100 years, and as technology has greatly improved, there are numerous methods for propelling a rocket. The simple science behind rockets has always been the same. So to propel a rocket, some kind of force must be expelled from the rocket in order to push forward. A force is the amount of push or pull on an object, and the mechanical force that pushes a rocket or aircraft through the air is known as thrust. So we'll see today in this experiment if the rocket will actually, separate itself and conduct a force of pushing back. My hypothesis for today's experiment is a simple rocket made with the balloon will be propelled down a string according to Newton's laws of motion because of thrust generated by pressure. So the materials that we're using for today are going to be balloons, and this is my little helper here. He's going to show us the supplies. Okay, so the first thing are the balloons. So you can get these from Walmart or any pharmacy or grocery store here. Just one pair. You just need one balloon, but I just bought a pack of these. The next are straws. You just need one straw, but like I said, I bought a pack of these again. And then you would need a string. You can get any type of string, but I got the cotton twine string, and you just need a yard of this, as well as some scissors and some tape. So what we did is we tied the string onto this pole right here. We tied a knot through here, and then I'm going to put the string through the straw. I cut the straw in half so the string can fit easier. And then we're going to tie the string to another chair. So next we're going to take the balloon and we're going to blow it up. And you're not going to tie the balloon up. You're just going to pinch it so the air is kept inside. So just like this, and you're going to pinch it so the air is tight. Do not tie it. So we put the balloon right here with the two straws. He taped the tape on the top of the straw right here, and I'm pinching the balloon, and we're going to see if it goes backwards. So make sure when you do the experiment that the pinch side will be on your right, and then the balloon surface is going to be facing the left. Okay, so we taped the straw on the top of the balloon here. The pinch side is facing the right, and we're going to see if the balloon is going to just move forward on its own. Ready, set, go. Okay, we're going to do the same experiment, but we put a carton on top of this. You put the tapes on the side of the straw and then also on the back to secure it. So we're going to see if this carton with the balloon travels all the way forward. Ready, set, go. To describe what happened with the first experiment of the balloon rocket, as I put the balloon set and I had the balloon pinched on my right side to make the balloon push forward, What happened when I let go of it was that the balloon traveled along the string track, and the pressure from the gases inside the balloon pushed those gases out of the balloon when it was released. What caused this to happen? Well, as the gases escaped the balloon, they exerted a force on the outside air, which in turn exerted an opposing force and pushed the balloon forward. In our second experiment with the cargo on top of the balloon, um, what happened as we added the cargo on the balloon rocket, the increased weight from the cargo slowed down the balloon rocket. So as you can see in the second experiment, the cargo with the balloon did not travel at all. It just literally exposed to the force of just falling down, and it did not move the balloon rocket at all. To show you a graphic data of what the visual experiment that we did, I want to show you here. If you could see this data here, the first experiment was this, how the balloon was pushed forward with no material or product holding it down, and the air just moved forward. You could see here with the second experiment with the balloon and the cargo, as it was pushing forward, the experiment did not work because of the weight of the object. So did I expect anything to happen with these both experiments? I want to say yes, because the first experiment, I did expect the balloon to push forward just because of the gas that was inside the balloon, where it forced the balloon to move forward at a speed where it was going to travel across the string. For the second experiment with the cargo holding onto the balloon, I did expect that the balloon was still going to travel across the room, but at a slower rate. But this was invalid because of the fact that the object was too heavy on the balloon, where the balloon did not travel across the string at all. So to conclude my hypothesis for experiment one, it was valid because the data supported my hypothesis, which the balloon did travel across the string. And for experiment two with the cargo holding the balloon, it was invalid because the data do not support my hypothesis. And I would reject my hypothesis and could form a new one, such as. To reference my experiment on my hypothesis and the results that were taken, in this experiment, the rocket is propelled by pressure. So, pressure, as you know, is the amount of force exerted on an area. When you blow up the balloon, you're filling the balloon with gas particles, mainly oxygen, and the gas particles move freely within the balloon and may collide with one another. As more gas is added to the balloon, the number of gas particles in the balloon increases, as well as the number of collisions. So while the force of a single gas particle collision is too small to notice, the total force is created by all of the gases particles collisions within the balloon is significant. As the number of collisions within the balloon increases, so does the pressure within the balloon. And in addition, the pressure of the gas inside the balloon becomes greater than the air pressure outside of the balloon. So the pressure inside the balloon serves as the fuel for the rocket. And when you release the opening of the balloon, gas quickly escapes to equalize the pressure inside with the air pressure outside of the balloon. According to Newton's third law of motion, every action has an equal and opposite reaction. Therefore, as the gas is released from the balloon, it pushes against the outside air, and the outside air pushes back. As a result, the rocket is propelled forward by the opposing force. This opposing force is thrust. So to compare to like a real world situation, in an aircraft or rocket, the engine provides power to the propeller, which produces the thrust. Power is the rate at which energy is converted or work is performed. So in general, an engine with more power produces more thrust. In addition, the thrust must be greater than drag in order for an aircraft or rocket to accelerate forward for takeoff and to increase its speed during flight. So if an aircraft is flying at a constant speed, the amount of thrust will equal drag.